In this video, we're going to learn how to solve quadratic equations by graphing. I can't write on this screen while I'm talking, so I'm going to make the video and then I'm going to watch the video, and while I'm watching, I'm going to make a set of notes to put in the OneNote with the video. So here we go. Suppose we want to solve the equation x squared minus 5x plus 4 equals 0. We're going to press y equals, and we're going to type in the equation x squared minus 5x plus 4, but you don't put the equal 0, so the y is where the 0 used to be. We're going to graph it using Zoom 6. Now, where is this particular graph equal to 0? Remember I said we replaced the y with 0, so what we're looking for are the x-intercepts. They appear to be at positive 1 and positive 4, but let's find out for sure. On the calculator, above the trace key, you see the word calc, C-A-L-C, second trace. This menu has lots of things you can do with graphs, and the thing we want to do is find the zeros. Zeros are the same thing as x-intercepts. They're also called roots, and they're also called solutions. Now you'll notice that the calculator at the bottom of the screen says left bound with a question mark. What we're going to do is we're going to build walls on either side of the 0. The 0 looks, by the way, like it's at x equal 1 right there. So we're going to move a little bit closer, but on the left. And then I'm going to hit enter, and it builds a wall on the left side of that x-intercept. Now I'm moving to the right because it's asking me for a right bound or a right boundary. I'm going to hit enter, and notice that there's little arrowheads pointing towards the center. Now it wants a guess, so technically we're supposed to move closer to the 0. And notice at the bottom of the screen it says 0, x equal 1, y equals 0. So one of the solutions of the original equation that I mentioned is x equal to 1. Let's go ahead and find the other one. I'm going to second trace. Number 2. Now I need to get on the left side of the other x-intercept. So that's close enough. Hit enter. Now it needs a right bound, so I get on the right side of the x-intercept, and then I make my guess, hit enter, and it gives me the other 0 at x equal 4, y equals 0. Now, there's another way we can find zeros sometimes, and that's by looking at the table of values. I'm going to go second graph, and here's a table of values. Notice when x is 1, y is 0. So 1 is one of the solutions of the original quadratic equation. When x is 4, y is 0 again. So x equal 4 is another solution of the original quadratic equation. Now notice the table, this particular table, all the x values are integers. So as you might imagine, if your root is not an integer, if it's a fraction or a decimal, then this technique might not help us find the root necessarily. All right, we're going to do another example. So we start at y equals. Now this particular equation is negative x squared plus 5x minus 2 equals 0. Negative x squared, let me just clear that, negative x squared plus 5x minus 2 equals 0 in the notes, but we're setting it equal to y, so that we can graph it. Now, when we look at the graph, we can kind of see that it crosses the x-axis somewhere between 0 and 1, and again between 4 and 5, but definitely not at exactly 1 or at exactly 5. So we're going to go to second, trace. We're going to choose 0. Now we're going to get on the left side of the x-intercept, and then we're going to move to the right side, and we build our two walls, and then we make our guess, hit enter, and we see that one of our zeros is 0.438447.2. Okay, now I'm going to find the second one. I need to build my left boundary, so I'm going to get closer first. So I'm putting up my wall on the left side. I'm putting up my wall on the right side. And so the calculator is going to search between those two walls for the 0, which is 4.5615528. Now, if we look in the table, notice the y value here. We know that zeros occur when y equals 0. Well, 1e negative 12 is 1 times 10 to the negative 12th, which is essentially 0. That's just a little bit of calculator rounding error. But let's go look at the table. You'll notice on the table that we don't ever see y equals 0. So let's look in the y column. I don't see any y values equal to 0. But I do see, let's go back up here, that my y value of negative 2 is followed by a y value of positive 2. For y to go from being negative to being positive, the graph has to be passing through 0, because negative 2, negative 1, 0, 1, and 2, to get from a negative to a positive, you have to pass through 0. And that's between x equals 0 and x equal 1. To remind you, one of our roots was approximately 0.4. And then if you go down to here, you'll notice that again, I have a positive y value followed by a negative y value. So somewhere between 4 and 5 is the other 0. And to remind you, it was approximately 4.5 or 4.6. Okay, let's do a kind of crazy looking example. This is going to be, let's clear it, 0.28 x squared minus 0.31x minus 5 equals 0. This is the equation I'm trying to solve. I'm setting it equal to y so that I can graph it and look for x-intercepts. Now, I would never, ever, ever in a million years try to factor that, nor would I want to plug those numbers into the quadratic formula, and I certainly wouldn't want to complete the square. So graphing is a great technique for this problem. So we're going to draw the graph, and you'll notice that there's an x-intercept between negative 3 and negative 4, and another one somewhere between 4 and 5. So let's find those. Second, trace 0. I need to make a wall on the left side of this x-intercept. Hit enter. Move to the right side. Hit enter. Go closer to make a guess. And I get 1, 0 at negative 3.71-ish if I were to approximate. So there's one of my zeros. I'm going to find the other one. Second calc, 0. I need to get on the left side, so I'm going to hit the right arrow because I'm trying to move over closer to the other x-intercept. Build my wall. move to the right side of the x-intercept, build my wall, move back, make my guess, hit enter, and I see that I have another 0 at approximately 4.82. If we look at the table, we're not going to find those zeros, but we are going to find y values that change from being positive to being negative. And that indicates that we passed through the number 0 somewhere between x equal -4 and x equal -3. And to remind you, one of our roots was -3.71. The other root, or 0, is down here. Notice my y value right there, -1.76. The very next step, it's now positive. So I crossed over the 0 somewhere between those two values. So I have a root between 4 and 5, and to remind you, it was 4.82. Another example, press y equals. We're going to solve 3x squared just get over here and delete this. 3x squared minus 2x minus 5 equals 0. We're plugging it in next to y so that we can draw the graph and find the x-intercepts. Now, this x-intercept on the left right here looks to be at -1. So I'm going to look at the table right away and see if that's true. Yes, it is. Look. At x equal -1, the y is 0. So x equal -1 is one of our answers. So I don't need to use the 0 command to find that. I'm going to go back to the graph. I'm going to go second calc, 0. I'm going to move to the left side, hit enter, move to the right side, hit enter, move back, hit enter, and the other 0 is approximately 1.6 repeating. Hey, 1.6 repeating, when you see a number repeating like that, that means it's pretty. So let's do this. Second quit. I'm going to go 1.6666. I'm just going to be typing 6s, lots of 6s. And then I'm going to hit math. I'm going to choose 1, which is fraction, and sure enough, that particular root is 5/3. 1.6 repeating is 5/3. That means, by the way, that quadratic, the fact that we got pretty answers, it means the original quadratic could have been factored. And I will probably, when I do the notes, I'll go ahead and show you the factorization of that quadratic, and we'll solve it that way too. All right, I've got 2 more examples for you. This next one is 1/2 x squared. So we're going to go alpha y equals, choose our fraction, 1/2 x squared minus 5x minus 12. Oopsie, minus, let me go back. I didn't get my 5. Second, insert 5. Okay, that's what I wanted. I'm going to hit graph. Now there's my parabola. I only see one of the branches and one of the roots. So if you can imagine, somewhere down here, this graph is going to cross the y-axis, and then it's going to turn around and come back up. It looks like the 0 we can see is at -2. And before I go any further, I'm going to look at the table and see if that's true. It is. There it is. Oh, notice another cool thing. When you use fractions on the y equals screen, your table automatically defaults to fractions. But you can see that x equal -2 is a 0 of the function. So that's one of our answers. Now, because I can't see the whole graph, I'm going to fly the plane a little higher off the ground, and by that I mean I'm going to zoom out. Enter. And I can see now that my other root is over here. So I'm going to find it. Second, calc 2. I'm going to move to the left side of this root that I haven't found yet. Now I'm going to move to the right side. I'm going to back up and make a guess. And I see that I have a 0 at 12. Well, that's interesting. That means that this original quadratic factored, because we got pretty answers. We got x equal -2 and we got x equal 12. All right, I'm going to go zoom 6 because I want to get my graphing screen back to sort of my home base. So now I'm going to hit y equals. We have one more example. This is a strange thing that might happen to you. Let me clear. It's -1/3. So alpha y equals 1/3 x squared minus 5/3. So alpha y equals 5/3 x plus 100. Again, this is a problem I would never ever factor, and I would never want to try to use quadratic formula on a equal -1/3, b equal -5/3, and c equal 100. That would not be fun. So we're going to look at the graph. And we know it's graphing because the little yellow spinny wheel in the upper right-hand corner. Now we know that it's done graphing, but where's the graph? Well, this particular parabola must be so wide and so big that it's off the screen. So we're going to zoom out and just see if we can find it. Oh, I have to hit enter. There it is. Okay, so I see my two roots. Second, calc 0. Oh, where's my... Okay, look at the bottom of the screen. That's an ordered pair. Watch what happens when I push the left arrow. You see how those values are changing and that y value is getting smaller? Here it comes down. I'm trying to get on the left side of the root, which in this particular problem corresponds to under the root. And now I'm going to the right, and you can see I've built my two walls. I'm going to make my guess, and I got a 0 of -20. I got a pretty number. Now I'm going to find the other one. Now I have to, move to the left side of the other root. This is going to take a while. Notice you can watch the ordered pair on the bottom of the screen. That will help you realize when your cursor's coming back into view. Should be any minute now. There it is. Okay, I'm on the left side of the root. I'm going to hit enter. Now I need to get to the right side of the root. Now I need to back up to the root. And I got another 0 of 15. So x equal what? The other one was -20 and this one is 15. I got two pretty roots. That means they're going to show up in the table, doesn't it? So let's go to, what did I say? -20. Yep, look, y equals 0, -20. And then also +15. +15. There it is. Whoa, whoa, come back. +15. And y equals 0. So 15 is the other root. We could have factored that monster too. Look at it. That factors. Probably would not even try that. Alright, so you can see how you can use the TI-84 to help you solve quadratic equations. And the really cool thing is you can use graphing to solve any freaky old two-variable equation. So you'll learn a lot more about that as the years go by. But thank you for watching.